Welcome back to another lesson in MCR3U. Today we'll be talking about entire and mixed radicals. So let's start off with a few definitions. When we look at rational numbers are numbers that can be written in fraction form. And so A and B, if we write it in fraction form, it's A over B. A and B are integers and B cannot be equal to 0. Rational numbers include terminating decimals, which means that these are decimals that stop and do not continue or repeat. So some examples of that are 1.25, 0.5, and periodic decimals, or occasionally called repeating decimals. So examples are 0.3 repeating, 0.6 repeating, so on and so forth. Here, when we look at irrational numbers, these are all non-terminating, non-repeating decimals. So irrational numbers will include something like pi, radicals, which are square root 3, square root 11, and some trig ratios, for example, sine 50. So when we think about radicals, which we looked at with square root 3 and square root 11, there's a couple of terms that you should understand. Again, number one, the radicals and the radicand. So the radicand is the actual value that's underneath the root sign. So here in square root 3, 3 would be the radicand, and 28 would also be the radicand in the cubed root here. When we think about mixed radicals, it's a radical that is multiplied by a number. So an example that we can write here is 2 square root 3. There's a difference between something like cube root 3 and 3 square root 3. So these are not the same. One of them is a cubed root, which means that it would be 3 to the power of 1 over 3. And the other one is 3 times square root 3. So there's a difference between those two. So just to be clear, and generally you can see the difference because the number at the front, if it's multiplied, is larger. If it's not, then it should be on the square root. So here this would be cubed root, and you can continue on with those different values as well. So now let's look at a couple of practice problems. So it says change entire radicals to mixed radicals. And how do we do that? And so here, when we look at the value of 24, we want to find values that are able to that are perfect squares. So if we think about some perfect squares, we have 4, we have 9, we have 16, and so on and so forth. And so we're trying to find those values and another value that may multiply to make it 24. So if we think about this here, we have square root. And if we think about it, we can do 4 times 6. And 4 times 6 would give us 24. And 4 is a perfect square. And so if we square root 4, and we can write it as two separate radicals that are being multiplied to each other. So here it's square root 4 times square root 6. We know that the square root of 4, because it is a perfect square, will be 2, and we'll be left with square root 6. So here we converted from square root 24 to 2 square root 6. And remember, mixed radicals is a radical that's multiplied by a number. And so here we have 2 square root 6. And the second one, so square root 98. So again, thinking about numbers that may be perfect squares. And in this situation, if we think about it, we can do 49 times 2. And 49 times 2, we can rewrite as square root 49 times square root 2. Square root 49 is the perfect square of 7. Square root 2. Square root 49 equals 7, and we have 7 square root 2. Here, when we have square root 50, think about again the two numbers. That'll be 25 times 2, square root 25 times square root 2 will give you 5 square root 2. And then lastly here, 180, if we think about that, we can get 36 and times 5. So we have 36 times 5, so square root 36 times square root 5 will give us 6 square root 5. And so those are a few examples of how to change entire radicals to mixed radicals. So let's look at this second example here. So when we add or subtract these radicals, so just as when we did in algebra, when there are like terms can be combined, like radicals can also be combined. So just like in algebra, where like terms can be combined, like radicals can also be combined. So if we look at an example, if we add like 5x plus 3x plus 2 minus 4, for combining the like terms, we know that 5x and 3x are the same. So that would be 8x. And we know that 2 plus 4, or these constants, can also be combined, which would give us -2. So in the same way here, we have to understand that the values that are underneath these square roots have to be the same. So in this situation, we see that both of them are square root 3. So we add them together, we just add the values that are in front. So here, 5 plus 4 would be 9, and we keep the radical the same in terms of square root 3. If you look at B, it's underlined the ones that are like radicals. So 4 square root 6 is like 6 is a like radical, and with 2 square root 6, and -3 square root 5, and 7 square root 5 would be like radicals. So here, if we write it down, 4 plus 2 would give us 6 square root 6 plus -3 plus 7 would give us 4 square root 5. Okay, so let's look at this example here, which should be C. So this example of C here has 2 square root 20 minus square root 125 plus 2 square root 45 plus 6 square root 5. As we see here, currently there is nothing that is a like radical. So what you want to do is you want to convert these values into ones that can be like radicals. So if we think about this question here, if we have square root 20, we can split that up into 4 times 5. Square root 125, we can square root that to make that 25 times 5. So similar to what we were converting up top, when we were converting from entire radicals to mixed radicals, we're doing the same process here so that we can combine the like radicals. Here we have 2 square root and 45. We can split to 9 times 5, and 6 square root 5 will keep the same. So here we see that 2 square root 4 times square root 5 minus square root 25 times square root 5 plus 2 square root 9 times square root 5 plus 6 square root 5. So let's simplify some of these. So here we know that square root 4 is equal to 2. So 2 times 2 will give us 4. Square root 5 stays the same. Square root 25 will give us 5. Square root 5. Square root 9 will give us 3. So 2 times 3 will give us 6. Square root 5. And we have 6 square root 5. So now here we see that all of them have square root 5 and they're all like radicals. So we can combine them all together and we get an answer of 11 square root 5. Okay, if we look at this last example, we're looking at now multiplying radicals. When we multiply radicals, we are simply multiplying the two radicands together. And so here we have square root 2 times square root 6. We can put that all under the same square root of 2 times 6, which will give us square root 12. Once we do square root 12, we can change that from an entire radical to a mixed radical when we split up 4 times 3, which is equal to square root 4 times square root 3, which is equal to 2 square root 3. Here, similar to, again, if you were going to multiply values that had a coefficient and a variable, so you keep the radicands, you multiply the radicands, and you multiply the numbers outside together. So in this situation, we have 3 times 2, which is 6, and then we multiplied the radicands inside, which are 2 times 5, which would be 10. Here we are using the concept of distributive property. So we're multiplying 2 squared 3 by square root 5, and then also to the negative 2. So here we have 2 square root 15 minus 4 square root 3. And then this last question here, we have 3 minus square root 6 multiplied by 2 plus square root 24. Here we're using the concept of FOIL. So the first, the outside, the inside, and the last. And so here we have 3 times 2, which is equal to 6. We have 3 times square root 24, which is 3 square root 24. We have 2 times negative square root 6, which would be negative square root 6, or negative 2 square root 6. And then finally we have negative square root 6 multiplied by square root 24. So it's square root 6 times 24. Here we can simplify a few of these. So 6 plus 3, I'm going to split up to 24 to 4 and 6. 2 square root 6 will keep the same. And here we can actually simplify this to, again, 4. 6 times 4 times 6 will split up to 24. Here, if we rewrite this, we have 6 plus 3 square root 4 square root 6 minus 2 square root 6 minus, and if we combine the two 6 values together, we get square root 36 times 4. And we want those because both of those are going to be perfect squares, which we can square root properly. So here we get 6 plus 3 times 2 because of the square root. So 3 times 2 will give us 6 square root 6 minus 2 square root 6 minus, so square root 36 would give us 6, square root 4 would give us 2, so multiply those together, gives us negative 12. Now we can combine everything that are like terms and like radicals, so we get a final answer of 4 square root 6 minus 6.